Hey, I'm in the car here driving in beautiful Langley because I wanted to talk to you a little bit about rates. And what a more well-known rate than the speed on your car or the speed of anything. We are traveling at a rate of 50 kilometers an hour because that's the speed limit, right? So you don't want to go more than that, of course, a higher rate than that, because of course it's illegal and it's dangerous and you might get pulled over. Now, we are about to come to a stop at a red light where we will have a rate of 0 kilometers an hour. Now, it's a rate, not a ratio, because you're comparing things that have different units. You see here on the speedometer, it says kilometers/hours. You're comparing kilometers and hours. A certain number of kilometers per 1 hour. So when we were traveling 50 kilometers per hour, that means that every hour, if you traveled for an entire hour at that exact speed, you will have gone exactly 50 kilometers, right? If you went for 2 hours, you would have traveled 100 kilometers if you stayed at that exact speed. Now, in reality, you stop at lights and you slow down for things and whatever else. So you're probably pretty hard to go at that exact speed for that long. But theoretically, that's what would happen. Now, we're about to move on to another street here where the speed limit is 70 kilometers an hour. So, of course, then if you traveled at that speed for 1 hour, you would have gone 70 kilometers. You're going faster. And, of course, as I said earlier, don't want to go more than that because of all the reasons I said. All right? Speed is an example of a rate, comparing things that have different units, kilometers, hours. All right, driving in the car, we were talking about how the speed of the car at the start was, I was going 50 kilometers an hour, because that was the speed limit. That's an example of a rate. Now, often you say 50 kilometers an hour in everyday speech. What the real term is 50 kilometers per hour. Okay, lots of times when you say something that has the word per in the middle, you're talking about a rate. Other ways to write it are more like it is in the sign here. 50 kilometers with that diagonal slash and an H. Or you could even write it as a fraction, the units. 50 kilometers per hour like that. Now what you're really saying is you're saying 50 kilometers per 1 hour. Every 1 hour you'll travel 50 kilometers. That's an example of a rate. It's a comparison of two quantities. Okay, just like a ratio, it's a comparison of two quantities. But the key is here that the two quantities you're comparing, if you look at this, we're comparing kilometers and we're comparing that to hours. You're comparing distance and time here. This is distance and this is time. And that actually gives your speed. That actually is the formula for speed. You're comparing two quantities, but the key part of the definition is here is the units are different. Okay, comparison of two quantities with different units. So that's important to know here. See, key term is a rate, and one of the key things here is comparison, but the units are different. All right, important to know. Now this rate here, this rate that we're looking at here, this speed, is actually an example of a special kind of rate. Special kind of rate called a unit rate. A unit rate is a rate where the second term in the comparison is 1. The word unit means 1. Okay, rate with a second term of 1. Okay, that's what a unit rate is. Again, the word unit meaning 1, right? And you can talk about rates even when you don't have a gauge or anything to measure them with. Anytime you have two numbers that you're comparing, and the units are different, that implies that you can write some kind of a rate to express that comparison. This interesting looking cartoon character here says, I ran 200 meters in 25 seconds. You can write that. Again, you can compare distance and time, right? Because you have a distance here, 200 meters, and you have a time here, 25 seconds, so you can make that comparison with a rate. That's actually going to be, we're going to write a speed for this. If we take distance and we divide it by time, that's actually how you calculate the speed of something. But that's a speed is a rate. Okay? So if we take our distance, which was 200 meters, and we divide that by our time, which was 25 seconds, this is a rate as well. Even before we divide it, it's a rate. Although this is a rate that's not a unit rate. Now, why is that not a unit rate? Well, if you look at the second term here, the second term is not 1, it's 25, right? This is still a rate. You're saying 200 meters, you travel 25, it takes 25 seconds to travel that far. But you can change it to a unit rate. We can express this as a unit rate if we just do the division here. Okay, if we divide these two numbers in our rate, 200 divided by 25, pretty sure, hopefully we can do this without a calculator, it is 8. But the units for our answer, we don't just say it's 8. You say it's 8 meters per second. The units for your answer, the units for the rate that you come up with, come from the things you're dividing. If you're dividing meters by seconds, you get meters per second. Okay? It's important to know when you have a rate, the units in the rate that you come up with come from the two things you're dividing. The last thing I want to look at is this little raccoon in this tree here. If we have one raccoon and one tree, we could say we have one raccoon, one tree. We got one raccoon per tree. You could write that as one raccoon per tree. He's got one tree to live in, one raccoon in that tree. But let's say we had more here. Let's say we had a bunch of these raccoons. So let's say we have 10 raccoons and 4 trees there. If we're going to try and make some kind of a comparison there, you could do it actually a couple different ways, because this is kind of such a goofy situation that I don't know whether I want to compare raccoons to trees this way, or I could write it the other way. I could do trees to raccoons. Oops, missed a C there. Okay, if I say I have 10 raccoons and 4 trees, that's a rate that I can write right there, right? And if I divide these two, not sure if you can do that without a calculator, but it actually is 2.5. Let's make this thicker. I'm having a hard time seeing that. Okay, it's actually 2.5, and the units would be raccoons per tree. Okay, meaning that you're going to have in every tree, on average, you're going to have 2.5 raccoons. Now, obviously, 2.5, you can't have half a raccoon living in a tree, but on average, between those 4 trees, there's going to be 2.5. Right? There might be 3 in some, 2 in the other, but it's kind of the average rate that they're, inhabiting the trees. You could do it the other way here, and you could say you have 4 trees and 10 raccoons. If you divided it that way, 4 divided by 10, you get 0.4, but the units would be the other way around this time. 0.4 trees per raccoon. Now that's a weird unit as well, right? It just wanted to emphasize that the units that you come up with, no matter how bizarre they are, like these ones, they come from the things you're dividing. If you're dividing raccoons by trees, you get raccoons per tree. If you're dividing it the other way around, if you're dividing trees and dividing that by raccoons, you get trees per raccoon. This means there's 0.4 of a tree that every raccoon's allowed to have, right? You get the fraction of a tree. Whereas this says there's 2.5 raccoons in every tree on average, right? That's rates. Rates, again, comparison of two things with different units. And you can have a special rate called a unit rate, where the second term is 1. All right, that's it.